Okay, we can get started with, does anyone have any questions or things they'd like to go over from last class before we dig into some Python programming some more? Okay. Well, if no one has any questions, we can just go straight into the concepts for today. So today we're going to be focusing on what we kind of introduced last time, but um, so I guess this goes along with using functions that are already created from different libraries, and sometimes we want to create our own functions. And so we're going to go over how do we do that. And then also another important concept is basically control flow. So we had a brief introduction to one of these examples when we were downloading a list of files in on the command line. So we're using one of those for loops. So that's an example of control flow where you have a series of tasks or decisions to be made. And so you can program that decision making with some features that we'll go over today. So let's start out with talking more about that control flow. And so kind of your most common task that you'd want to do is to perform an iteration over a list or some kind of series. But there's also other cases where maybe you don't know exactly, so you're not iterating through a list, but you want to keep on repeating a loop and doing something until it basically finds a certain value or something like that, where then it will stop. And then also really helpful when we're doing these for loops and especially while loops is using these if or else statements. So these are kind of basically you're checking conditions, whether they exist. And so this allows you to do, like if you're doing a for loop, you could say maybe if the output is even, print even. If it's odd, print odd. So it allows you to do certain things like that. And again, these are kind of very simple examples, but these are the foundations for a lot of the functions that you would need when you're writing your own programs or scripts. So in Python, the way that we do this is there's three different options if you're doing kind of this true false logic, which is if, else if, or else. So basically you can, with if, define the first condition that should be met. And so say you're iterating through numbers and you want to see if a number is even, you could say if the number is even, do this, else if the number is odd, do something else. And I guess this wouldn't be necessarily applicable in this condition, but then any other thing that you want to do with the remaining output that doesn't meet any of these conditions up here, then that can be performed with this else statement. And so with the else statement, you don't need to define a condition, you just say else, and it's basically assumed everything else, do this. And the way you do this within Python, so to basically indicate that some task is part of a parent task, you'll be using indentation. So I think I have an example. Yeah, so here's an example where say we wanted to check input to see if it's less than 100. You could say if y is less than 100, then you do the indent, do task A, else do task B. And I kind of wrote this out in a pseudocode fashion like we talked about before, but the actual implementation will be just slightly different, but not by much. So the way we would actually write this down, and if we're doing this here, we would say if y is less than 100, and then after that condition is specified, you use a colon, and then on the next line you would use a tab, and then you can say, well, print this is a small number. And then for every other number, we can say print this is a large number. And I haven't defined that, but I can do that right now. And then I'll just re-implement that. Oh, I guess I accidentally ran large number twice, but this would, in this case, print out this is a small number. And this doesn't have to be just a one line task. This could be manipulate the input this way, and then this way, and then return the output. There's a lot of different things that you can do with this. So say there's an example where, let's say y equals 1,000. And we wanted to have the same general setup where this is a large number, but say we didn't want to specify any other tasks to be run. We only want to do something if y is less than 100. So we can actually just leave this as is and run it, and it's not going to do anything. Or alternatively, if we want to just kind of keep track of where we are in these testing conditions, and we still want an else statement, or maybe there's some like intermediate, I guess we could say, so in Python else if, so the next one is elif. So maybe if it's greater than 100 and y is less than 200, then we don't want to do anything here, so we can say pass. And then maybe for all the other conditions, this is where we print out this is a large number. And since that, what we had set y to is not within this range, we're going to get some print function executed at some point. So you're not just limited to saying less than or greater than. So you can basically do any mathematical operator. If you want to check if something's greater than or equal to or less than or equal to, you need to specify the greater than or less than sign first and then an equal sign afterwards. And say if you wanted to check if something is equal to something, so say we had z equals 100. If we wanted to see if z was equal to 100, or maybe we want to say if z is equal to 101 in this case. So we set that condition using a double equal sign. So double equal sign is checking for whether or not something's true, where it's not setting something equal to a variable or setting a variable equal to something. So if we were to run this, if z is equal to 101, print yes. But since it's not equal to that, it's not going to evaluate. Then we can just run this where we will set it equal to 100, and then we get that yes output. Inversely, if you want to check if something was not equal to something else, then you would just use a exclamation mark equal. And so the exclamation mark in Python and in most programming language, that basically means not. Okay, and then like I had shown before, if you wanted to test two conditions at the same time, so here we're checking if something was in a range of two numbers, you can either use the ampersand sign or you can just write and. So that's a nice thing about a lot of Python programming is it's very, I guess you'd call it verbose, where if you were kind of thinking about this condition out loud, that's exactly how you would type it out. If you wanted to check an or situation, so say if z equals 100 or z equals hello, do something, so you can use this pipe symbol or just type or. And so here's an example where we can make a pretty complicated condition checker where we can basically, for a series of ranges, do tasks A, B, C, or D. So there's a lot of different options of what you can do. So are there any questions so far about any of these concepts? Is this making sense? Yeah. So now let's talk about for loops, how to implement those within Python, and then also combining for loops with condition checks. So we talked about how we would implement a list last time, where we're setting a variable equal to a list, which is specified with brackets and commas. And so here, very similarly to how we would do in shell. So let's say I had, let me change the formatting real quick, since the PDF is going to mess up the formatting. So we could say for x in a, this can be literally anything, word, we can say print, in this case, we set that subpart of the list equal to word during the iteration. So you can say print the word, and then this will go through that list and print every item on a new line. But then we can combine this with those conditional statements. So if we say, in this example, so if the length of the word, so if the length of hello or word or exclamation mark is greater than 2, only print out that item from the list if it meets this condition. And similarly, we can say maybe, so you can also use this length item to check the length of a list as well, not just the number of characters in a string. So you could say if the length of A is greater than 2, then for x in A, print x. And since that first condition was true, it's going to print out each of the items. And I just want to point out, so with here, you can see that example of indenting where since this task is one indent in from this for loop, this task and any with the same indenting amount belongs to this for loop. Whereas with this if statement, just anything one indent from that will belong to that. So that's why it basically isn't running this if statement for every loop or something like that. If we were to just say if this and then not use this, it's going to give us an indentation error because it basically is expecting some kind of task to be indented from this statement there. Okay. So I mentioned earlier, there might be some situations where we don't necessarily know how many iterations we want to run. And so it's not just defined by the length of a list or whatever it might be. So we could do something like this where we'll use what's called a while loop. So basically what this is going to do is while y is less than 10, keep on doing whatever's underneath it. And so in this example, we can see we start y at 0. We say while y is less than 10, print hello. And then for each of these iterations, add 1 to y. So we can add 1 using this syntax where we do a plus equal. So that just basically means y equals y plus 1. Or you can, instead of using this, you can type out y equals y plus 1. And then similarly, if you want to do y equals y minus 1, you could say y minus equals 1. So if we were to just to run this real quick to look at the output, we would see that you'd see that we get hello printed out 10 times. And so maybe in this case, maybe y is a user input. So this could be variable where we don't know exactly how many loops we're going to do. And so that's where you'd want to use a case where you're doing a while loop, because you may need to do 10 iterations. You may only need to do 5 based on that input there. But just to kind of demonstrate how this is flexible, if we were to restart this while statement and each time only add 0.5, it's going to take twice as many iterations to meet this condition where y is less than 10. And so we're going to get twice as many hellos. And then with all of these things, or even just simple print statements, it doesn't have to be within a for loop or a conditional statement. Any kind of component of this coding, if it's something that we're going to want to reuse over and over again within a script, or maybe we just want it available within a utility Python script, we can wrap these into functions. So a function has 4 different components. It has basically the definition of that function where you give it a name and basically define any inputs. There's the inputs themselves. There's the tasks to be done once the function is started. And then there's the outputs from that function. And a function doesn't have to have outputs, or doesn't even have to have inputs, but those are, I guess, optional. So the way you would define a function is you would say def space the function name, and then within parentheses you would define any variables followed by a colon. And then any component of that function needs to be one indent level within that. So if we wanted to just make a very simple case where there's no inputs, we could just say this function hello with no inputs, print hello. And then if we were to call hello, whenever you call a function, you need to have that name along with those parentheses. And if there's input variables, you have those included. If not, it can just remain empty. And so we get that whatever was defined within that function to be run. So another case, we could require one input from the user, and what this function would do is to take that input, add one to it, and then return that modified x value at the end. So if we were to run this as is, we would get 2. And the only reason we're able to get this output is because we have this return statement at the end. So if we want an actual variable to be returned, we need to have that return statement at the end. And say we wanted to save the output of this function. So you'll see here in this example, we didn't save the output. And so if we tried accessing x after we run the function and x hasn't been defined before, we're going to get an error saying x is not defined because x was only defined within the scope of this function. Whereas if in this case, if we wanted to save the output, we would just say x equals add 1 with the input, and then we would be able to access 2 from the x variable afterwards. So there's that example there, what we just talked about. If you wanted to deal with multiple inputs, you can separate those inputs with a comma. So for maybe a more complicated mathematical function, we could do this where we use those 2 user inputs, run that function, and then return the output of that function at the end. And so here you would just say the function name 1, 2, and then it would perform that calculation with those 2 variables. What about multiple outputs? So here we could have multiple inputs or just a single input. And here we can combine, so we'll use some if statements to basically modify or determine what y will be. And if x is over 100, we'll also modify the x value. And if it's less than 100, then we won't modify the x value, but we will set x to something. And then if there were multiple, so we could, maybe we just want to return y here, so we just say return y. But if we want to return multiple components, then we can just separate those with a comma. So we just say return x comma y. And if we wanted to save each of those individual variables that were available there, we would just, when we're defining the variables that we want to set the outputs of the function to, we would just separate those by a comma. So let's just say let's say run test with no inputs, and we will return 1 and 2. So these could be variables x and y, or you can just return values like this as well. So we could say x comma y equals run test, and then x will equal to 1, y will be equal to 2, just like we expect. But say we just ran x equals run test. Now when we run x, it's going to give us all the components of that return function, basically. So if you're providing multiple outputs, it's best practice you should be providing it as many variables to save to as there are outputs returned from a function. Okay. This is a pretty short lesson for today. So the homework assignment to practice these would be to create a list of strings, and for each element in that, or for each string within that list, basically determine if the number of characters in that string is greater to 5, less than 5, and do different operations based on that. And then here's another one. But with each of these assignments, I would practice running basically just this component. And then after you've tested how to set this operation up, then turn that into a function where maybe you allow the user to give variable inputs, and then you perform this operation. So that in this case, if the user input was greater than 5, just print out the string. If it was less than 5, then print out this is a small word. So are there any questions from stuff that we covered today? Okay. Well, I will stick around until people sign out, but if you have any questions before you sign out, feel free to ask them.
I had a question about a previous thing.
Okay.
When we were downloading the SRA tools, we were just going over this earlier.
Okay.
You open the file in Excel and you wanted to save it as a tab delimited file. I was wondering why you would save that Excel file. Is it just to have a reference?
So why you would save it as a tab delimited file,
Or just why you had the Excel file, you opened it on the desktop and then because I had to open it with Excel and then do the thing where it became tab delimited. So I was just wondering, well, other than teaching us how to do that, was there a reason you would download the metadata to an Excel file?
Yes, I think, actually, I don't remember this. Do you know if it gives options for different formats when you download the SRA?
I didn't get any.
Okay. I think I want to say that it's by default just an Excel spreadsheet, but I may be wrong.
Okay, I also changed my default to notebook, so
okay,
that's probably why I had to do it that way. I was just
gotcha. Yeah, it may already be a tab file. I guess just if it's already a tab delimited file when you download it, then you can just use it as is. If you're reading it into Python or some command line tool. But if it is like an Excel spreadsheet, then you'll need to convert it.
Mm-hmm. I've been trying to avoid Windows. Well, I was just wondering why you opened it in Excel, like, and if you had a reason to have an Excel file with the metadata in it, if that was just a reference or.
Yeah, that was just a reference file.
Okay.
if this was
Like,
downloading using the SRA toolkit, I was just basically
you're just
copy and
showing us different
pasting.
things. Okay.
Well, so that's downloading that metadata file is nice if you're wanting to download a large data set. So maybe something has like 40 samples.
Mm-hmm.
Instead of having to go into each record in the geo database individually,
Right.
you can just pull up the whole metadata table and quickly access all those IDs.
It got really frustrating until I figured it out. Then I was like, why do we even have this? I'm going to ask.
Yeah.
So I just like, must be a reference or a easy way to download it. The
Yeah.
SRR number.
That's all that was for that case.
Okay.
Yeah. I mean, if you're, yeah.
We're trying to get caught up with the homework right now. So we're doing study sessions and stuff, and it's helping.
Cool. That sounds good.
So
yeah, if you're running into any issues, just let me know and I can walk you through things. Or if there's just something that isn't totally clear, I'm happy to go back and cover one of those concepts again.
Yeah, I was just curious about that, but yeah, I've got that working so far.
Cool.
Hopefully we're going to do another study session tomorrow, so hopefully we'll be more caught up for Friday.
Okay, sounds good.
All right, well, thanks for your time.
Yep, see you on Friday.
See you Friday.